2,000 years ago, engineers drilled more than 1,000 feet underground. They didn't use steel, they didn't use engines, they didn't even use metal pipes. They used bamboo. And what they built worked for centuries. This isn't a myth, it's documented engineering. Ancient China created machines so precise, so well designed, that some of them still outperform modern solutions. Not because we can't improve them, but because the original designs already solved the problem completely. Today, you're about to see 20 inventions that don't feel ancient at all. They feel inevitable. This video uses careful cross-checking of findings, archaeological discoveries from UNESCO sites, research from the Met Museum and Cambridge University, ancient Chinese historical records. Every claim has been checked against multiple sources. By the end, you'll understand something mind-blowing. China's old engineers operated on a level we're still trying to reach. The #1 invention will blow your mind. It's so advanced that modern scientists still study how it works. Section 1. The impossible engineering. Get ready. What you're about to see will shatter everything you think about old technology. We're starting with 4 inventions so advanced that modern engineers still can't figure out how they did it. 20. Deep borehole drilling, 2nd to 3rd century CE. Imagine you need water in a desert. Your survival depends on reaching underground water. Get it wrong? Your civilization dies of thirst. Get it right? You control the most valuable resource on Earth. In the year 200 CE, Chinese engineers drilled wells over 2,250 feet deep. That's deeper than the Empire State Building is tall. They did it with bamboo and hand tools. Take a moment to realize what this actually means. No engines, no steel rigs, no electricity, just gravity, patience, and an understanding of materials most civilizations never even attempted. In Sichuan province, they built bamboo towers called heaven carts. These towers reached hundreds of feet high. Then they connected them with hundreds of miles of bamboo pipeline. By the Song era, their wells went over 1,000 meters deep. For context, depths like this wouldn't become common until industrial drilling existed. Chinese wells already exceeded that depth by over a millennium. The Zhejiang region alone produced 150,000 tons of salt every year in the 1850s. Salt wasn't just seasoning, it was money. It preserved food, it kept armies fed. Control salt and you control empires. What makes this remarkable isn't just the depth, it's the mindset. Instead of forcing nature with heavier materials, they worked with flexibility, pressure, and repairability. This wasn't primitive engineering. It was systems thinking, centuries ahead of its time. But underground drilling was just the beginning. What if I told you they could predict earthquakes without electricity? 19. Zhang Heng's Seismoscope, 132 CE. Earthquakes kill without warning. In old times, they were seen as angry gods. Predict them, you're a prophet. Miss them, thousands die. In 132 CE, Zhang Heng created a bronze dragon that could feel the earth shake 250 miles away. And it worked every single time. This wasn't magic, it was pure mechanical genius. Zhang Heng created a bronze bowl with 8 dragon heads pointing in different directions. Inside was a pendulum so sensitive it could detect ground shaking from earthquakes hundreds of miles away. Here's the story that proves it worked. Court officials were skeptical when the device showed an earthquake in a distant province. No one felt anything locally. They thought Zhang Heng was wrong. Then, days later, a messenger arrived confirming the distant earthquake. The court was stunned. When earthquake waves reached the device, the pendulum swung toward the earthquake's direction. This triggered a mechanism. A bronze ball dropped from a dragon's mouth into a frog's mouth below, showing the direction of the quake. Modern earthquake detectors are more precise, but Zhang Heng's device has something ours don't. It works forever. No electricity, no batteries, no maintenance. This changes how we think about ancient science. Earthquakes weren't treated as supernatural punishment. They were treated as physical events that could be observed, measured, and interpreted. Speaking of mechanical genius, imagine a computer so advanced that modern engineers spent a century trying to reverse engineer it. 18. South-pointing chariot, 3rd century CE. You're leading an army through unknown territory. No GPS, no compass. Get lost? Your entire force dies. Navigation wasn't just important, it was survival. Chinese engineers built a chariot with a wooden figure on top that always pointed south. No matter which way the chariot turned. It was like having a GPS system made of gears and wood. Stop and picture that. Direction encoded into motion itself. No magnets, no stars, no external reference at all. This wasn't just a clever toy, it was mechanical computing. The chariot used a gear system so sophisticated that when modern engineers tried to recreate it in the 20th century, they had to use differential gears. The same technology in your car's transmission. Ancient Chinese descriptions were so advanced that historians thought they were impossible. Modern engineers literally reinvented this chariot because they couldn't believe the ancients figured it out first. They used purely mechanical rotation math to solve navigation problems. We still use this exact principle in modern navigation systems. They invented mechanical computing 1500 years before we thought it was possible. This wasn't about finding south. It was about turning movement into information, a machine that could reason without thinking. But what makes this even more incredible? They were also perfecting the same stabilization technology we use in smartphones today. 17. Gimbal, Han Dynasty, approximately 180 CE. You're burning incense in a moving carriage. Spill it? You've disrespected the gods. Keep it level? You've mastered physics. The challenge? How do you keep something perfectly stable while everything around it moves? Ding Huan solved this in 180 CE. He created an incense burner that stayed perfectly level no matter how you moved it. The secret? Multi-axis rotation. Ding Huan's gimbal used rings within rings that could rotate independently. This allowed the inner chamber to stay level while the outer structure moved in any direction. Here's what will amaze you. This is the exact same principle used in your smartphone's camera stabilizer, in spacecraft gyroscopes, in ship compasses. We have Tang dynasty specimens made of silver that still exist today. The principle hasn't changed in 1800 years because it solved the problem completely the first time. Once you solve motion in 3 dimensions this cleanly, there's nothing left to improve, only materials to swap. Your phone's camera stabilizer, the International Space Station's gyroscopes, ship navigation systems, they all use Ding Huan's gimbal principle. Now imagine if I told you they were also creating the ancient world's answer to automatic gunfire. Section 2. The Modern Warfare Revolution. What you're about to see will change how you think about old warfare forever. While European armies used swords and shields, Chinese military engineers built weapons that wouldn't look out of place on a modern battlefield. 16. Repeating crossbow. Chu state origins. You're facing an enemy army. Your archers shoot one arrow, then spend precious seconds loading the next one. In that time, cavalry charges, soldiers die, battles are lost. Chinese engineers solved this with the Chu Ko Nu, a crossbow that could fire 10 bolts in 10 seconds. One soldier could unleash a storm of projectiles faster than an archer could load a second arrow. The repeating crossbow had a magazine that held 10 bolts. Pull the lever back, push it forward, 1 bolt fired, no reloading, no aiming delay, just continuous fire. Picture this battlefield scenario, 112 firing positions, each shooting 1 bolt per second, That's 6,720 bolts per minute raining down on attackers. That's not a skirmish weapon. That's a system designed to overwhelm human reaction itself. It was like facing a machine gun 1,500 years before machine guns existed. We still use this exact principle today. Modern assault rifles work on the same concept. Mechanical simplicity plus sustained rate of fire. The Chinese figured out automatic weapons over 1,000 years ago. But they weren't just revolutionizing projectile weapons, they were weaponizing chemistry itself. 15. Chemical warfare, poison smoke balls, Song dynasty. Your city is under siege. The enemy has superior numbers. Conventional weapons aren't enough. You need something that turns the air itself into a weapon. Song dynasty engineers created the world's first chemical weapons. They mixed gunpowder with lime and arsenic. This created choking, blinding clouds that could clear entire sections of battlefield. The molten metal bombs used in the 1129 siege were so effective that historical records describe their impact. Wherever the gunpowder touched, everything would disintegrate without a trace. These weapons didn't just hurt, they terrified. They made soldiers question whether they were fighting humans or demons. They achieved effective chemical warfare within low-tech constraints. No precise laboratory formulation needed, just clever chemistry and battlefield psychology. What's more terrifying than poison clouds? How about the ground itself becoming a weapon? 14th land and naval mines, 14th century Ming. You're invading enemy territory. Every step could be your last. The ground looks normal, but death waits beneath. How do you fight an enemy that can make the earth itself explode? Ming dynasty engineers turned familiar terrain into a psychological nightmare. They created hidden explosives triggered by tripwires and slow-burning fuses that could detonate hours after being set. These weren't simple bombs. They were sophisticated weapon systems with poetic names like sky-soaring thunder. Mongol invasion records describe armies paralyzed by fear, afraid to advance because any step might trigger an explosion. The genius was in the simplicity. Low-tech trigger mechanisms achieved remarkable reliability using only materials available in that era. Modern landmines work on the same basic principles. But here's what will really blow your mind. They were building the world's first rocket artillery systems. 13. Multi-stage rockets, Ming dynasty. You're commanding a fortress under siege. The enemy has thousands of troops. You have hundreds. You need something that can unleash devastating firepower instantly. Ming engineers created the fire dragon issuing from the water, a multi-stage rocket system that could fire 320 rockets in a single devastating barrage. Think about that. This wasn't experimentation. It was coordinated deployment. The system used modular rocket pods that could be swapped out like giant building blocks. The rockets had secondary payload ignition. The first stage launched the projectile, then a second stage ignited to extend range. This is multi-stage rocketry. The same principle used in modern space launches. Every modern military uses these exact concepts. Modularity for rapid reload. Coordinated firing for maximum impact. Multi-stage rockets for extended range. The Ming dynasty invented modern artillery tactics 600 years ago. Now prepare yourself. We're about to enter territory that will make you question everything you know about the Industrial Revolution. Section 3. The Industrial Revolution, 1,000 years early. Everything you learned about the Industrial Revolution is wrong. Schools teach you it started in 1800 Europe. But China was already mass-producing iron, powering factories with water, and moving goods through continental logistics networks 1,000 years earlier. 12th Blast Furnace, 5th century BCE. Iron is civilization. Control iron production. You control armies, tools, and empires. But iron melts at over 2,800 degrees. Get the temperature wrong? You get useless metal. Instead of shaping iron one piece at a time, Chinese engineers approached the problem at scale, treating iron as a flowable material that could be cast, standardized, and multiplied. They invented the blast furnace in the 5th century BCE, over 2,000 years before Europe figured it out. By the Han dynasty, iron implements became so abundant they transformed agriculture, construction, and warfare. While Roman blacksmiths hammered individual pieces, Chinese foundries cast hundreds of identical tools from liquid metal. Modern blast furnaces use the exact same principles. We've improved materials and added computer controls, but the basic physics haven't changed. Chinese metallurgists figured out industrial iron production 2,500 years ago. But they needed massive amounts of air to power these furnaces, so they invented a pump so efficient we're still using the same design today. 11th, double-action piston bellows, 4th century BCE. Your blast furnace needs constant, powerful airflow. Stop the air? The fire dies, your iron production stops, your economy collapses. Chinese engineers solved this with pure mechanical genius. They created a 2-chamber piston system that pushed air on both the forward and backward strokes. No dead time, no wasted motion, continuous blast. Traditional bellows only pushed air on one stroke, wasting half the human effort. The Chinese double-action system used both directions of movement, doubling efficiency instantly. In the 1st century CE, they adapted it to water power. Tu Shi connected these bellows to water wheels, tripling efficiency again. Now they had automated continuous air supply without human labour. We still use this exact principle in modern air compressors, hydraulic systems, even bicycle pumps. The Chinese figured out maximum mechanical efficiency 2,400 years ago. They were also solving logistics problems on a scale that wouldn't be matched for centuries. 10. Canal Pound Lock, 984 CE. You're moving grain to feed millions of people. Your boats are loaded with tons of cargo, but rivers have different water levels. Hit the wrong current? Your boat smashes apart. In 984 CE, Qiao Weiyue invented the pound lock. It's the same system used in the Panama Canal today. The basic physics haven't changed in over 1,000 years. Ships entered a chamber, gates closed, water levels adjusted, gates opened. Simple, elegant, perfect. Every major canal system in the world uses this exact design. The Panama Canal, the Suez Canal, European river systems. They all copied Qiao Weiyue's invention. We haven't improved this design in 1,000 years. Not because we can't, but because it's already perfect. But what makes this even more impressive? How they integrated it into the world's most advanced logistics network. 9. The Grand Canal Logistics System, 7th century onward. You're running an empire with 60 million people. Food grown in the south must feed armies in the north. Fail at logistics? Your empire collapses. Chinese engineers built a 1,000-mile supply line that connected North and South China. Grain, taxes, and troops flowed on schedule across distances equivalent to crossing the entire United States. They did it using only water, locks, and administrative genius. The Grand Canal enabled centralized control of food supply and military logistics on a scale never before achieved. The system was so effective, it remained the backbone of Chinese logistics for over 1,000 years. This wasn't just moving food, it was stability flowing through water. Modern logistics companies study this system. Amazon's distribution network uses the same principles. The Chinese figured out continental logistics without computers, trucks, or trains. Speaking of engineering marvels, they were also building ships that could survive what would sink modern vessels. 8. Watertight bulkheads, 1st century CE. You're crossing the ocean in a wooden ship. Hit a rock? Water pours in. In minutes, your ship sinks. Everyone drowns. Chinese shipbuilders solved this by dividing ships into sealed compartments. Hit one section, only that section floods. The rest of the ship stays dry and functional. In 1974, archaeologists salvaged a Song-era ship from Quanzhou port. It had watertight bulkheads. The ship was over 800 years old, and the compartment system was still intact. To prove the design works, engineers built a reconstruction in 2008 called the Princess Taiping. It successfully sailed from China to San Francisco, an 800-year-old design crossing the Pacific Ocean in the 21st century. Every modern naval vessel uses this exact principle. Aircraft carriers, submarines, cruise ships, they all use compartmentalized design descended from Chinese shipbuilding. Now we're entering the realm of medical and scientific mysteries. Section 4. Medical and Scientific Mysteries. While European doctors still used leeches and bloodletting, Chinese physicians and investigators developed techniques so advanced that modern science is built on their foundations. 7. Forensic Entomology, Song C, 1247 CE. A murder has been committed in your village. No witnesses, no fingerprints, no DNA testing. The killer could be anyone. You need evidence that can't lie, can't be bribed, and can't be intimidated. In 1247 CE, Song Si solved a murder using blowflies. He invented forensic entomology 700 years before the West even knew it was possible. A farmer was found dead, killed with a sickle. Song Chi gathered all the village men and told them to lay their sickles on the ground in the hot sun. Within minutes, blowflies swarmed to one specific sickle. The owner broke down and confessed. Song Sui understood that blowflies are attracted to invisible traces of blood and flesh. Even after cleaning, microscopic residue remains. The flies could detect what human senses couldn't. Modern forensic entomology uses the exact same principle. Crime scene investigators still study insect behaviour to determine time of death and evidence of foul play. Song Si figured out that insects don't lie, but they weren't just solving crimes. They were preventing diseases in ways that saved millions of lives. 6th, the first vaccine, 10th century onward. Smallpox was killing 1 in 3 children. Entire royal families were wiped out. The disease showed no mercy. Find a way to stop it, and you save civilization. 7 centuries before Edward Jenner, Chinese doctors were deliberately exposing people to weakened smallpox to make them immune. It was the world's first form of vaccination, and it saved millions of lives. The method was sophisticated. Doctors dried and ground scabs from mild smallpox cases, then blew the powder into a patient's nostril through a silver tube. The Kangxi Emperor had his entire royal family and army treated this way. Millions of people received this early vaccine. Every vaccine you've ever received uses this same principle. Long before microbes could be seen, immunity was already being engineered. COVID vaccines, flu shots, childhood immunizations. They all work by controlled exposure to trigger immune responses. The Chinese figured out immunology 1,000 years ago. And if you think that's impressive, wait until you see the mechanical masterpiece that contained the heart of every watch you've ever owned. 5. Susong's Clock Tower, 1088 CE. You need to track time, predict eclipses, and coordinate a vast empire. Get the timing wrong? Religious ceremonies fail. Agricultural planning collapses. In 1088 CE, Susong built a 40-foot water-powered astronomical clock that housed the same ticking mechanism found in every mechanical watch today. It wasn't just a clock, it was a computer. This tower had 3 levels: a rotating armillary sphere that tracked star positions, a celestial globe that showed the night sky, time-announcing bells that rang automatically. Susong invented the escapement mechanism. the ticking heart of all mechanical timepieces. His system used gravity-driven water containers that filled and emptied in precise intervals, creating the regular tick-tock rhythm. The escapement principle Su Song perfected is still the core of every mechanical watch. That ticking sound, that's Su Song's invention from 937 years ago. We haven't improved the fundamental mechanism. But we're just getting started. The final 5 inventions will completely revolutionize how you see the foundation of modern civilization. Section 5. The global game changers. Everything you're about to see built the foundation of modern civilization. Without these 5 innovations, you wouldn't be watching this video right now. 4th, movable type printing, 1040 CE. Knowledge is power, but only if you can spread it. Copying books by hand takes months. One mistake ruins the entire manuscript. In 1040 CE, Bai Sheng created movable type printing. Gutenberg gets the credit 400 years later. But Bai Sheng approached printing differently, not as a single machine, but as a modular system where information itself could be rearranged and reused. Bai Sheng used ceramic pieces, each one a single character, arranged on iron plates coated with resin, wax, and paper ash. The concept was revolutionary: modular, reusable type that could be rearranged for different texts. When this technology reached Europe 4 centuries later, it transformed the world. The printing press enabled the Renaissance, the Reformation, the scientific revolution. Every font on your computer uses Bai Sheng's principle. Digital typography, laser printing. Even this video's text overlays. We're still using his idea nearly 1,000 years later, but spreading knowledge required something even more fundamental. 3. Paper money. Tang flying cash, approximately 804 CE. You're a merchant travelling 1,000 miles. Carrying enough coins for major purchases means hauling hundreds of pounds of metal. Bandits target wealthy travellers. One robbery, you lose everything. When moving metal coins became impossible, China invented paper money backed by government authority. That's literally how modern currency works today. It started with Tang dynasty flying cash around 804 CE. Merchants could deposit coins in one city and withdraw them in another using paper certificates. The Song dynasty took it further, shifting to state-printed paper currency backed purely by government authority. Every dollar, euro, and yen works on this principle. Your credit cards, bank transfers, digital payments, they're all descendants of Tang dynasty flying cash. Modern economics is built on China's 1,200-year-old innovation, but they needed a way to navigate the oceans to spread these innovations globally. Second stern post rudder, 1st century CE. You're crossing the ocean in a massive ship. Steering with side oars is impossible. The ship is too big, the current's too strong. Before Europe even dreamed of sailing the ocean, Chinese ships had already figured out how to steer them with a rudder mounted at the stern. This innovation won them the seas. A pottery model of a Chinese junk from the Han dynasty shows a stern-mounted rudder. This was discovered in Guangzhou in 1954, proving the technology existed 2,000 years ago. Once ships reached a certain size, side steering stopped working. The stern post rudder was the solution, and once invented, it became unavoidable. The stern post rudder enabled control of massive vessels, making long-distance ocean exploration possible. Every ship today uses this exact design. Aircraft carriers, cruise ships, cargo vessels, they all steer using stern-mounted rudders descended from Chinese innovation. And now, the #1 invention that will completely blow your mind. 1. Porcelain. Tang dynasty, high-fired ceramics, 7th century. You need a material that's harder than steel, more beautiful than glass, more durable than stone. It must be waterproof, heat-resistant, so fine that light passes through it. Tang dynasty potters created porcelain, the world's most advanced composite material. For certain applications, nothing has fully replaced it in 1300 years. This wasn't just pottery, it was materials science. Chinese potters used kaolin clay found near Jingdezhen, fired at extremely high temperatures to create a hard, semi-translucent, waterproof ceramic unlike anything the world had ever seen. Porcelain became so valuable it was literally called white gold. European royalty paid fortunes for Chinese porcelain. Entire trade routes existed just to transport it. When absolute reliability matters, this is still the material we choose. Dental implants, electrical insulators, high-end cookware, laboratory equipment. 1300 years later, we're still trying to match what Tang dynasty potters perfected. When you step back, a pattern emerges. These inventions weren't random flashes of genius. They targeted the same pressure points again and again. Energy, movement, food, time, disease, information. Ancient Chinese engineers didn't chase novelty, they solved bottlenecks. And once a bottleneck was solved, entire systems unlocked. That's why these inventions don't feel ancient, they feel inevitable. 20 inventions, 2,000 years of innovation. One undeniable truth, sometimes the ancients got it so right, we're still catching up. From drilling technology to vaccination, from mechanical computers to global economics. Chinese inventors didn't just solve problems, they solved them so elegantly that we're still using their solutions today. Remember when I asked you to imagine drilling 1,000 feet underground with bamboo tools? Now you know it wasn't imagination, it was reality. 20 inventions that prove human genius isn't about having the latest technology. It's about solving problems so perfectly that time can't improve them. These ancient engineers didn't just build machines, they built the foundation of everything you use today. If this changed how you see human innovation, hit subscribe. Sometimes the oldest solutions really are the best solutions.